Okay, picking back up with arithmetic sequences and partial sums. Um, Example 4 is asking us to use the recursion formula. Um, you can or you can't. It just kind of depends on what you're more comfortable with. So it says find the ninth term. So again, let's list what we need and what we have and all that good stuff. It wants the ninth term. So if you want to, come over here and we want a sub 9. Okay. And we want it such that it begins with 2 and 9. Now they're kind of being sneaky here. They're telling you that a sub 1 is 2 and a sub 2 is 9. You can also infer the difference because 9 minus 2 is 7. So hey, they gave you a lot of information here. So what we can do is we can use our handy dandy formula. Remember, a sub n equals a sub 1 plus d times n minus 1. Let's use this, and we can generate our formula for a sub n. Then you can go back and get whatever term you want. So a sub 1 needs to go here. Common difference is 7. We're leaving n in there. Remember, we're just wanting to come up with that formula. Clean that up. 2 minus 7 is, okay, let's see here, 7n minus 5. This is my a sub n formula right there. Now we want to get specific. We specifically want a sub 9. Okay, step over here, put 9 in the place of n, and work it out. So 7 times 9 is 63 minus 5. That would be, I do believe that is 58. So a sub 9, 58. If you want to come back up here and put it up there, that's just fine. We really didn't use the recursion formula. We just used what we already had. So if you want to, keep the things that you have to remember to a minimum, there's an idea for you. Okay, swap gears. Remember the title here is we're doing arithmetic sequences and partial sums. This is the partial sum portion of the lesson. So time to swap formulas. Our formula here is s sub n equals n over 2, and then we've got a sub 1 plus a sub n. Okay? Very, very good formula. Just a brief little history lesson here. Try to keep it short. This was devised by Carl Friedrich Gauss way back several hundred years ago. The way he devised this thing is, if you would think about numbers, a sequence of numbers, like it was a string. Like if you had the numbers 1 to 1,000 all in a string, and you took that string and you folded it in half, then the numbers 1 would be right beside 1,000, and 2 would be by 999, and this would be 998, 997, 996, right? And then just think about it. If you folded it literally in half, this would be 500, and this would be 501, right? Well, if you summed them up, we have 1001, 1001, 1001, blah, 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 even down here, 1001. How many 1001s do you have? Well, look, we have 500. There's 500 1001s. Well, didn't we say that we had 1,000 numbers? 1,000 over 2 is 500, right? And our first number was 1, and our last number was 1,000. So this is n over 2, and this is a sub 1 plus a sub n. It is our formula right there. Gauss came up with this when he was 5 years old. So kind of impressive there. That's where this formula came from. Okay, so finding the sum of a finite arithmetic sequence. It works lovely for any sequence that you have, but it doesn't need to be finite. If you remember, that just means it has a definitive end. If you look at this, a sub 1 is 1. A sub n, our ending one, is 19. Now we do need to know how many terms you have. So if they don't tell you, you need to either find it out with intuition or you need to just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you could say, hey, this is the odd numbers all the way up to 20. Doesn't it have to be half of them? Yes, it does. So there are 10 numbers. So this n being 10, that means you got n terms. So then you're going to come over here, and you're going to be using your formula. N over 2, a sub 1, a sub n. So that is n over 2. So 10 over 2, a sub 1 is 1, a sub n is 19. So we have 5 times 20. 5 times 20, that's 100. And that should make sense because think about it. If you kind of rainbowed these out, isn't that 20? And these two, that's 20. These two, 20 again, 20. And there's another 20. So that's the same thing, right? 5 20s. Lovely formula. Lovely. Okay, same idea as what I spoke to you about Gauss here, so no need to really do this again. We can do it the fast way, I guess. N over 2, oops, a sub 1 plus a sub n. They're telling you here that there are 100 numbers. So you put 100 there, because when they say 1 to 100, yeah, that's all 100 terms. So we put a 1 and we put 100. So we got, what is that, 50? And this is, oops, 101. If you multiply that out, it's kind of weird, 50-50. This might look a little strange, because if you did that, you don't know how many terms, it's n. Well, you leave the n in there. Your first term is, well, 1, and your last term is n. You're done. That's as far as you can go. That's your sum. Okay, now find the 150th partial sum of the arithmetic sequence. Now, to me, this is just weird language, but what that means is you want to sum up the first 150 terms. So that's what this means. The sum of the first 150 terms. That's what they're getting at, okay? So, remember our handy-dandy formula. S equals n over 2, and then we got a sub 1 plus a sub n. Well, all the things that we need to know what n is, we need to know what a sub 1 is, we need to know what a sub n is. Well, they were nice. N is 150. We got to do 150 of them. A sub 1, well, they gave us the sequence. It's 5. They did not give us, see, we're going to need to, let's replace this. It's 150. We don't know what the 150th term is. We've got to go figure it out the same way we figured out stuff before. So let's just take a moment. We've got to go back and use our little formula. A sub n equals a sub 1 plus d times n minus 1. Well, this takes us back to needing to know good old d. How much is the step? That looks like plus 11, doesn't it? This thing is stepping by 11s. So d is 11. If we come in here, we can get our little formula. A sub 1 is 5. We have 11 minus 1. So 5 plus 11n minus 11. 11n, put our 5 minus 11, what is that, minus 6? So there's our formula. Now, if we want to know what the 150th term is, we need to come in and put in 150. Well, I have no idea what that is. I need a calculator. So let's see here. 11 times 150 minus 6. That's 1644. So 1644 is what I need. So let me scoot over here. I think we're ready to go. We know what n is. That's 150. We know a sub 1. That was 5. And now we know a sub 150. 1644. We're good to go. So this is going to be 75, and this is going to be 1649. Again, I do not know that. I need a calculator. So let's take 75 times 1649. Woo! 1, 2, 3, 6, 7, 5. So 123,675. Gets really big really fast when you're summing up all those sequences. Okay. All right, let's try a different one. We're moving into word problems at this point. It's the same basic concept though. When you read through it, you got this golf tournament. There's 16 golfers with the lowest scores win cash prizes. The first place, ace of one, he receives $1,000. Second place, $950. Now I could write them all, but that's good enough right there. What is D? Minus 50. And it does tell you on and on and so forth. What is the total amount of prize money? So what this is asking me for, this is asking me for the sum of all the prizes. So n over 2, a sub 1 plus a sub n. But what is n? How many prizes were there? Go back up here. 16 golfers. So I know I am summing up 16 things. But the hiccup, once again, is the exact same problem that we had in the previous one. We need to know a sub 16. So, y'all, you really do the exact same thing. So, a sub n equals a sub 1 plus d times n minus 1. Put your a sub 1 in there. 1,000. You know your d is, now your d is negative. This is our first one with a negative. Take the plus sign out and just replace it with a minus, okay? And then I got n minus 1. When you distribute, you're going to have 1,000 minus 50 n plus 50. So I'm going to have, let's see here, 1,050 minus 50n. So if I want to know what a sub 16 is, I've got to come in here and plug in a 16. So I've got 1050 minus 50 times 16. That came out to be 250. So the last place got $250. So if you come in here to your sum formula, you've got 16 prizes divided by 2. First place, $1,000. Last place, $250. That turns into 8. This is $1,250. Multiply those out. It comes out to a perfect $10,000. But again, same thing. Well, guess what's going to happen in the next problem? You got it. Same thing. Different scenario. Small business sells $10,000 worth of skin products during the first year. Ooh, sound familiar? First year. Okay. The owner of the business has set a goal of increasing the annual sales by $7,500 each year. So they gave us a different piece of information. They gave you D. That's what you're stepping by year after year after year. Okay, they're wanting to do it for 9 years, assuming that this goal is met, so you actually do it. Find the, here we go, total sales, n over 2, and then we've got a sub 1 plus a sub n during the first 10 years. So n is 10. So if I come in here, I've got 10 over 2. First year was 10,000. But again, guys, you got to have a sub 10. I don't know a sub 10. I've got to go figure it out. I'm a little scrunched there, so let's put him down here. A sub n equals a sub 1 plus d n minus 1. And I'm going quick because I know I'm running out of time. I've got 10,000 plus 7,500 n minus 1. So if you go through and you distribute that, you got 7,500 minus, oops, put my n on there now. Okay. I got like 30 seconds at this point. Let me see if I can find the end result of this. This all ends up being a total of 77,500. And if you come in here and you put your 77,500 and you work this one out, you get 437,500. Y'all play with these. Make sure you come back and you get your formula sheet. Try your homework because we're going to have a quiz next time I see you. Okay? Y'all need to practice. Stay on top of things.